Assalamualaikum and hi to Dr. Today I will be presenting about regression modeling. I will explain about historical origin, statistical versus deterministic relationships, regression versus causation, regression versus correlation, and some examples of simple and multiple linear regression. So the history of regression. The term regression was first introduced by Sir Francis Galton in the late 19th century. He used it to describe a statistical phenomenon he observed while studying the heights of parents and their children. Galton found that tall parents tended to have shorter children on average, and short parents tended to have taller children on average, meaning that the children's height regressed toward the population average. This concept, known as regression toward the mean, later became the foundation for modern regression analysis. For the next step is statistical versus deterministic relationships. A statistical relationship between two variables means that they are associated in a predictable way, but there is some variation due to randomness or other influencing factors. In contrast, a deterministic relationship means that one variable completely determines the other without any randomness. For example, the relationship between the radius and area of a circle is deterministic, as you can see in the formula, while the relationship between a person's height and weight is statistical because other factors influence weight. Now we move on to regression versus causation. Regression analysis helps identify relationships between variables, but it does not prove that one variable causes the other. Causation means that a change in one variable directly leads to a change in another, while regression only shows an association or pattern. For example, a regression model might show that ice cream sales and drowning incidents are related, but this does not mean eating ice cream causes drowning. Instead, a third factor, hot weather, influences both. For regression versus correlation. Correlation measures the strength and direction of the relationship between two variables but does not assume one affects the other. Regression, on the other hand, goes a step further by modeling how one variable predicts another. Correlation is symmetrical. Yes, for example, x and y are equally related, while regression assigns one variable as independent and the other as dependent. For example, height and weight may have a high correlation, but a regression model might predict weight based on height. Now for examples of linear regression models, we move to a simple linear regression models first. A simple linear regression model predicts a dependent variable using only one independent variable. For example, predicting a student's test score based on study hours. As you can see in this graph, the line for this, the correlation between independent and dependent variable. Next up, we have an example for multiple linear regression models. A multiple linear regression model includes two or more independent variables to improve predictions. For example, predicting test scores based on study hours, sleep quality, and previous grades. Multiple regression provides a more detailed understanding but requires careful analysis to avoid misleading results. Here is the graph for with two or more independent variables to predict a future test score. So that's all from me for this presentation. Thank you.